Hi, everyone. My name is Shoumik Palkar. I'm a software engineer at Databricks. Today, I'll be talking briefly about Photon, a new high-performance query execution engine we've been developing for our Lakehouse platform. To provide some quick background, what is a Lakehouse? The Lakehouse storage architecture essentially means that we want to be able to provide the speed and structure of a data warehouse with the flexibility, open formats, and economies of scale of a data lake such as Amazon S3. The Lakehouse allows users to execute more traditional SQL-like BI workloads on the same view of the data as emerging workloads like machine learning and data science. One challenge with the Lakehouse is that we can see data in any stage of its life cycle. A Lakehouse can hold clean, structured tables that BI tools access, intermediary data that may have been clustered and coalesced but not denormalized, and also raw data that, for example, uses placeholder strings instead of nulls, and has many small files. In such an environment, the burden of good performance ultimately falls on the query execution engine. Photon is a new 100% Apache Spark compatible query engine designed for speed and flexibility. It's built from the ground up to deliver the fastest performance on modern cloud hardware for all data use cases, be it BI, data engineering, data science, or data analytics. So why build a query engine from scratch? To motivate this, here's a normalized performance chart of every Databricks runtime version since 2016. Performance has continued to increase over time, but in relatively small increments. For example, it took us 5 years to get a 3x overall speed up by incrementally improving the old engine. With Photon, right out of the gate, we are twice as fast and 6 times faster than where we were 5 years ago. In the context of our platform, Photon sits at the lowest level and performs the work of executing tasks on partitions of data. Today, the JVM and Spark are still responsible for orchestrating these tasks. Spark is also responsible for traversing the query plan and converting it into a representation that Photon understands. In the data plane, Photon and Spark can communicate using the Java native interface and can pass data between each other using pointers to offload memory without copying. We'd categorize Photon's design into 3 big decisions. First, we use an interpreted vectorized execution model. This allows us to support microadaptivity, which is important for adapting to the various kinds of data we see in the Lakehouse. It also allows us to hand implement SIMD kernels for speed. Second, unlike the rest of the runtime platform, Photon uses native code. This allows us to avoid issues with the JVM, GC, and JIT, such as limits on method sizes or performance clips with the optimizer. Third, Photon is integrated with Spark and is completely transparent to users. We can transition between a Spark plan and a Photon plan automatically, so this lets us roll out Photon incrementally as we add more features. I'll dig into the first of these 3 points a bit more, since it's the most interesting from a database perspective. So why did we choose an interpreted vectorized execution model? This model is based on the MonetDB system, and the high-level idea is to decompose a query into execution kernels that process cache-sized batches of data. We use runtime dispatch to decide which kernel to run for a given input. This model is very cache and CPU friendly, and it's also adaptive by nature. We can always choose a different execution path based on runtime data properties. Compared to code generation, the other popular alternative, we found that we could get similar performance with many quality of life improvements like richer metrics and faster development. So it wouldn't be an interesting performance talk if I failed to show you the obligatory TPCDS performance chart. So here it is. This plot is showing Photon speedups versus DBR on each TPCDS query for the 3 terabyte scale factor. The average query speedup is 2.5x, and the end-to-end runtime for executing the whole benchmark is 3.7 times faster. And finally, I have to talk about our audited TPCDS results. With Photon, Databricks was able to beat the official world record on the TPCDS power run on 100 terabytes, beating other data warehouses with an open format and over commodity cloud storage. In summary, Photon is a bleeding edge execution engine built for our Lakehouse use case. If you like working on these kinds of projects, we are hiring. Thank you.